Hello. This question comes from the Year 12 Maths Methods Official Exam paper, VCAA VCE, from 2017, Exam 1, Question 2. As I'm sure many of you, well, all of you would know pretty much, in Exam 2, there's the first section, which is multiple choice, and the second section, which is extended response questions. And amongst the extended response questions, there were 4 extended response questions, and if you look at the exam report, then from the exam report, you can work out the average mark achieved in each one of the extended response questions. Amongst the students that sat this exam, the average mark for question 1 was 31.8%. The average mark for question 2 was 40%, and the average mark for question 3 was 50%, and the average mark for question 4 was 47.22%. And if you work out the average mark for all of the extended response section, it came out to 51.2% pretty much, which isn't too bad compared to other years. Because some years it's been in the average mark for the extended response section has been in the 40% mark. Now, the extended response question with the lowest average mark, which was 40%, was question 2. So you can arguably say that overall, question 2 with the lowest average mark was arguably the most difficult extended response question. And what was question 2 about? Well, question 2 was about, as you can see, a Ferris wheel. As I'm sure most of you would know, you can download the Year 12 Maths Methods VCA VCE Official Exam Paper 2017 Exam 2 onto your screen or onto a printer, so that you can see this question a bit better. Now, what is the question about particularly? Well, the question says this: Sammy visits a giant Ferris wheel. Sammy enters a capsule on the Ferris wheel from a platform above the ground. The Ferris wheel is rotating anti-clockwise. The capsule is attached to the Ferris wheel at point P, which is shown here in the diagram. The height of P above the ground, h meters, is modeled by h equals 65 minus 55 cos pi t on 15, where t is the time in minutes after Sammy enters the capsule and h is measured in meters. Sammy exits the capsule after 1 complete rotation of the Ferris wheel. So that's the Ferris wheel, that's the capsule, they're the individual capsules that rotate anti-clockwise, and that's the point P, and that's the height, h meters, above the ground, platform. A, state the minimum and maximum heights of P above the ground. Well, according to the question, the height of P is given by the equation h equals 65 minus 55 cos pi on 15 t, where h is the height in meters and the time t is in minutes. Now, the height will be given by the height equation 65 minus 55 cos pi on 15t. Well, this is a relatively easy question. The center line is given by 65. Center line is given by 65, and the amplitude is 55. So you will go down 55 and go up 55. 65 minus 55 is 10, and 65 plus 55 is 120. Of course, if you know how to do this question quite easily, you can answer this question in about 1 or 2 seconds by simply saying 65 minus 55 is 10 meters. Now we move on to the next question. Question B. Now, what is question B about? Question B says, for how much time is Sammy in the capsule? Well, it says here in B that how much time is Sammy in the capsule? Well, Sammy will be in the capsule for 1 rotation. So therefore, the time it takes to go around 1 rotation is called the period. The period for sine and cos graphs is equal to 2 pi on n. And that's equal to 2 pi, what's n? Well, according to the question, the height is given by that, so n will be pi on 15. So n will be given by pi on 15, and as a result, you work it out, 2 pi divided by pi on 15, 2 pi, as they teach in grade 5 fraction theory, when you've got a fraction divided by a fraction, you keep the first fraction the same, change the divisor times, upside down the last fraction, and in the end, you get 30 minutes. So the amount of time that he will be in the Ferris wheel will be 30 minutes. Question C. Find the rate of change of h with respect to t, and hence state the value of t at which the rate of change of h is at its maximum. Well, when they say find the rate of change of h with respect to t, that's just a fancy way of saying find the derivative. Well, of h. Well, h is 65 minus 65 cos pi on 15t. Now, of course, because this is exam 2, where you can use a CAS calculator, then it's the quickest way of finding the derivative of h is to use the derivative function on the CAS calculator. You can use the, of course, you can use the TI Inspire or the Casio or any other CAS calculator that you got at your disposal. But let's say that such a question appeared in exam 1, and in exam 1 you can't use any calculators whatsoever. You would have to work out h by hand. And how would you work out h by hand? Well, just very quickly, I rewrote in black the height equation. H equals 65 minus 55 cos pi on 15t. They want us to work out the derivative of h, dh dt. So you put a red d dt on one side, and it's the old storyline. Whatever you do on one side, you do on the other side. You put a d dt on the other side. And then, like they And then, like they should have taught you, every time you go derivative and in the middle of the derivative, you go to minus, you split up that one derivative up into two, as shown here. Now, the derivative of 65 is 0, and you're left with this part here. Again, as they should have taught you, when you've got a derivative and you've got a constant inside the derivative which multiplies everything else, you can take that constant out. So you take that constant out. Which is 55 in this case. Then you work out cos pi on 15t using the shortcut, or if you like, using the chain rule. You put the biggest possible red chain around it, which gives you negative sine pi on 15t, and then you put in a smaller blue chain, which is pi on 15, which is pi on 15. Can you do a smaller chain, the blue chain? No, you can't. And then you just clean it up. So therefore, the HCT is equal to, so therefore the HCT is equal to 55 pi on 15 sine pi on 15t. Of course, like I said before, please in the exam, work out the HCT using the derivative function on your CAS calculator. I just went through that just to give you guys a bit more practice on finding derivatives. Now, so, okay, in the first part, so, and I mean, then of course, you can clean it up a bit, cancel it down. What goes into 55 and 15? It's 5, so divide by 5, and 55 divided by 5 is 11, and 15 divided by 5 is 3. And you end up with the HCT is equal to 11 pi on 3 sine pi on 15t. Okay, now, so we've done the first part of the question. So the first part of the question said, find the rate of change of h with respect to t. We've done that, the HCT. And hence, that is, with the information that you get to start so far, state the value of t at which the rate of change of h is at its maximum. Well, look, the reality is this. If you know what you're doing, you can work out this second part of the question in about 1 or 2 seconds. But if you're a little bit unclear about how to do such a question, then perhaps one way of clarifying it is to take this approach. Okay, graph the HCT equal 11 pi on 3 sine pi on 15 t. Well, it's a sine graph. So y equals sine x, that's a typical sine graph. And from your typical sine graph, you can put in 11 pi on 3, which will give you 11 pi on 3 and negative 11 pi on 3. And the pi on 15 will give you a period, like we saw before, of 30 minutes. So that becomes 30 minutes. So the graph of the HCT equal to 11 pi on 3 sine pi on 15t is actually that. From the graph, when will the HCT be a maximum? It will be at that point. When will that occur? It will occur at 7.5 minutes. Why? Because that's 30 minutes. Sine graphs are symmetrical. Half of 30 minutes is 15 minutes. Half of 15 minutes is 7.5 minutes. So that's why the HCT will be a maximum at time equal to 7.5 minutes. So we've answered the second part of the question, which was, I'm sorry, I've got something in my throat. Hence, state the value of t at which the rate of change of h is at its maximum. We've answered that question. Now we move on to the next question. Now, what is the next question? The next question is part D. And in part D shows again a Ferris wheel, and it says the following. As the Ferris wheel rotates, a stationary boat at B on a nearby river first becomes visible at point P, subscript 1. B is 500 meters horizontally from the vertical axis through the center C of the Ferris wheel, and angle CBO is equal to theta, as shown below, over there. Find theta in degrees correct to 2 decimal places. So, okay, that's point P subscript 1, that's point C, and that's the boat at B. That distance there is 500 meters, and that's angle theta. And they want us to find angle theta. How do you find angle theta? Well, I've redrawn this diagram over there. Well, we know from question 2A, from our height equation, that the maximum height achieved by the Ferris wheel will be 120 meters, and the center line we saw from our height equation was 65 meters from the ground, and the lowest point of the Ferris wheel was 10 meters. We saw that from question 2A. Now, the length from here to here on the question is 500 meters, and that angle there is theta. And they want us to find angle theta. Now, at which point, to find angle theta, we have to just redraw triangle VCO. And I've redrawn triangle VCO down here. It's 65 meters, 500 meters, 500 meters, and that is angle theta. And we can work out angle theta by using good old SOHCAHTOA. And when we do that, we will see that angle theta, it will be what? It will be opposite on adjacent. So using SOHCAHTOA, it's going to be tan theta equals opposite on adjacent. So therefore, tan theta is opposite is 65 on adjacent, which is 500. So tan theta will be equal to 65 of 500, 0.13, and then theta will be inverse tan 0.13, which is 7.41 degrees. And we worked out theta. Now we move on to question E. What is question E about? Well, they say part of the path of P is given by y equals square root of 3025 minus x squared plus 65. X is between negative 55 to 55, where x and y are in meters. find dy dx. Now, the first part of the question says part of the path of P, which is this one here, is given by y equals square root of 3025 minus x squared plus 65 for x between negative 55 and 55. Now, at first glance, some students would say, what are they talking about when they say that y equals square root of 3025 minus x squared plus 65? It is true that the question is saying just simply find dy dx, and you can find dy dx by using the derivative function on the CAS calculator. And you'll get the full marks, which is 1 mark. But very quickly, let's sort of demystify this question a little bit better so that you can feel a little bit more confident in some ways in regards to the rest of this question. What do they mean by P being on y equals square root of 3025 minus x squared? Well, that's explained by the following worked out solution. Well, firstly, y is equal to the square root of 25 minus x squared plus 65. Work out dy dx on the CAS calculator. That's of course the best way of doing it. It's the quickest. Now, of course, if you want to do a bit more practice by hand in regards to working out dy dx, that's the worked out solution. That's the worked out solution. I went over the previous, we went through the previous DHVT solution, and for this solution here, you got it on the screen. So if you want to look at this worked out solution, you can pause the screen and look at it. Okay. And then the remaining part of this worked out solution, is here, and by hand, and you work it, and you end up with dy dx is equal to negative x on the square root of 25 minus x squared. Okay, but of course, please, in the exam, because you haven't got much time, please work out dy dx on the CAS calculator, or else you're just going to increase your chances of running out of time. Now, going ahead here. Now, the question is going back to the question that I was asking before. What do they mean when they say in the question, part of the path for P is given by y equals square root of 3025 minus x squared plus 65? Well, that's explained by doing the following. The whole Ferris wheel can be seen as being a circle, where the center of the circle is at y equals 65, and the radius of the circle is 55 meters, because that's the amplitude of the height equation. Now, we know that when we got a typical ordinary circle where the center of the circle is at the origin, its equation is x squared plus y squared equals r squared. Well, okay, we got x squared plus, now in the y direction, the circle went up by 65. Every time something is within brackets, we do the opposite. So we put in minus 65 in the brackets. And the radius of the circle is 55, so you put in radius 55. So you end up with x squared plus y minus 55 squared equal to 55 squared. and you end up with x squared plus y minus 65 all squared equal to 30/25. And at which point we find y, that is, get y by itself. And when you get y by itself, and when you get y by itself, you put the and when you get, and you got at which point you got to get y by itself, put the x squared on the other side, and you get y minus 65 all squared equals 30/25 minus x squared. And then get y by itself, you square root both sides to get rid of that square, and you get y minus 65 square root of 30/25 minus x squared. And then you bring this minus 65 on the other side, and you get the equation that they got. Y, which is shown in the exam, which is y equals, y equals square root of 30/25 minus x squared plus 65. In other words, what they're saying in the exam is that the equation of that circle, which is the Ferris wheel, it's just simply y equals square root minus x squared plus 65. That is, that's just the equation of a humble circle. Now, okay, so the question is saying find dy dx. Okay, so we found dy dx. Now we proceed ahead. Now, the next part is this. The next part is this. The next part is this one here, which is part F. Now, part F has the Ferris wheel continues to rotate. The boat at B is no longer visible from the point P2 UV onwards. The line through B and P2 is tangent to the path of P, where angle OBP2 is equal to alpha. Okay, that's a setup. So they're saying to you that from about here to about here, you can see the boat. But once the Ferris wheel goes past that point P2, you can no longer see that boat out there, which is 500 meters horizontally away. Find the gradient of the line segment P2B in terms of view, and hence find the coordinates of P2 correct to 2 decimal places. Again, the question is saying find the gradient of the line segment P2B in terms of view, and hence find the coordinates of P2 correct to 2 decimal places. Okay, how do you do it? Well, I've redrawn the diagram here. That's P2, that's B. Now, they say in the question that the coordinates of P2 are UV, at which point, and they say that this green line from P subject 2 to B is a tangent line. Now, the first thing that you need to do here is you're going to find in one way or another the gradient of the you got to find in one way or another the gradient of the tangent line P2B. How do you do that? Well, in calculus, you should know that the gradient of the black circle at x equals u is equal to the gradient of green tangent line at x equals u. Then we proceed ahead to the next stage. What's the shorthand fancy way of saying gradient of black circle at x equals u? It's to say, the shorthand way of saying gradient of black circle is say dy dx at x equals u. That's equal to the gradient of the green tangent line at x equals u. At which point, what's dy dx in this question? Well, we saw before, it was negative x on the square root of 30, 25 minus x squared at x equals u. And that's equal to gradient of green tangent line at x equals u. So you're putting x equals u into here, and you end up with negative u on square root of 30, 25 minus u squared. And that's equal to gradient of green tangent line at x equals u. And we've answered the first part of the question. Now, the second part of the question says the following. Find the gradient of the line segment P subject to B in terms of u. Done. And hence, that is, with the information that you gathered so far, find the coordinates of P subject to correct to 2 decimal places. How do you do that? Well, the way you do that goes along these lines. Now find coordinates of P2 to 2 decimal places. Well, we got here a diagram, and we got P2 is at U, and we got P2 has got a Y on it here of V. Now, and we know that the gradient of this green tangent line from our previous part of this question is in a negative u on the square root of 30, 25 minus u squared. P2's got a y on it of y sub p2. You find y sub p2 by putting x equals u into the equation of the Ferris wheel circle, which is y equals square root of 30, 25 minus x squared plus 65, which comes out to y sub p2 equals square root of 30 minus u squared plus 65. Now, at which point, we know from the question that the horizontal distance from C to B is 500 meters. We also know that that's u. So that means that the horizontal distance from C to U is u. So that means that if that distance there is 500 meters, then that distance there must be 500 minus u, which is 500 minus u. What's the next stage here? The next stage is the following. That the gradient of the green line, that the gradient of the green tangent line is equal to the gradient of any line, rise on run. And that is equal to what? Well, the rise of this green tangent line is equal to that height there. Is equal to that height there. And that height there is given by the y on it, which we just worked out, which is square root of 30, 25 minus u squared plus d5. all right? And you're going to put a negative at the front because the line is going down. Remember, every time a line goes down, it's going to negative gradient. All over the run. What's the run? What is the run? The run of this green tangent line will be equal to 500 minus u. So you put 500 minus u here. Then you get, then you clean it up a bit. Negative times everything inside on 500 minus u. And let us not forget that from the previous calculation, we know that the gradient of the green tangent line is also equal to negative u on the square root of 3025 minus u squared. Now, at which point we got an equation with one unknown, which is u. And you can find u by using the solve function on the CAS calculator, and you end up with u equals 12.9975. That is, u comes out to 13.00 to 2 decimal places. Now that we've found out what u is, you can find the corresponding y-unit or v by putting u equal to 13 into the equation of the circle, and it comes out to 118.44. And you would have found u and v like that. Now we go on to the next bit here. So at which point, what do we know? We know now that P2, which according to the question, had coordinates u, v, where u we have just worked out as being 13.00, and v, as we just worked out, has got coordinates of 118.44. So that question F has been done. Now we go on to question G. Now what's question G about? The second last question. Find alpha in degrees correct to 2 decimal places. Well, okay, we're going to find alpha, which is this angle here. Well, I've redrawn this diagram somewhat here. What do we know? Well, we know that that's a green tangent line, and that point P2 is 118.44, and that's 13. So alpha belongs to this triangle here. So that triangle there. So as a result, we can say that the rise is 118.44, and the run of that green line is 500 minus 13. 513 is 487. And using good old Sokotoa, we got angle alpha opposite on adjacent, tan theta equals opposite and adjacent. Opposite is 118.44. On adjacent, 487. And it gets a tan alpha equals 0.2432. Get alpha by itself, inverse tan, 13.67 degrees. Done. Now we get to question H, which is the last question, which is arguably the most difficult question sub-question in this question 2. H says the following. Hence, otherwise, find the length of time to the nearest minute during which the boat at B is visible. Hence or otherwise, find the length of time to the nearest minute during which the boat at B is visible. The way we do this question is the following. It is a difficult question. There's no doubt about it. And you can see from the exam results that students didn't do too well. The way we do this question takes the following approach. Now, they're telling us this, that's the Ferris wheel, and he can see the boat from P1 right up to P2. We know that P2 is at 13 and 118.44. And we know that the boat is last seen, he first sees the boat at P1, and when that happens, the gradient is 0.13. Now, at which point we know also from question 2D that angle there is 7.41. And we also know from question 2D that the gradient of that green line is 0.13. Also, we know from question 2G, that angle there we just worked out as being 13.67. And we've also worked out from question 2G that when the boat is last seen, that blue line there's got a gradient of 0.2432. Now, from all that, we can see that angle there, will be equal to that angle minus that angle. 13.67 minus 7.41. What's 13.67 minus 7.41? It's 6.26. If you can't see it too well on the video, I apologize. But that angle there, which I've written down in pencil, is 6.26. Now, and then the other thing that must be noted here is that this is a triangle. And because that blue line, as stated by the question, is a tangent line, then if you rule the radius line from P2 to C, then that angle there is a right angle. So if that's the case, what is that remaining angle in the triangle P2CB? That remaining angle is equal to, well, like you know, the sum of all internal angles in a triangle is 180 degrees. So therefore, that remaining angle will be 180 minus 90, which is 90, and 90 minus 6.26, which is 83.74. So that angle there is 83.74. So that angle there is 83.74 degrees. Now, therefore, that means that from when he can see the boat over there to when he no longer sees the boat over there, his rotational distance is 83.74. At which point we can go to the next stage. We can redraw that blue Ferris wheel circle over here, and he can see the boat from P1 to P2 through a rotational distance of 83.74 degrees, period during which boat can be seen. So we now know that the rotational distance over which you can see the boat out far is 83.74 degrees. From that, we can work out for how long you can see the boat. How? Well, we know that the Ferris wheel travels around 360 degrees when the Ferris wheel goes around once in 30 minutes. So, as a result, therefore, we have the following. To go around 360 degrees, it takes the Ferris wheel 30 minutes. And as a result, to go around 83.74 degrees will take the Ferris wheel W minutes. Hey, we've got a ratio going here because that's degrees, and that's minutes, and that's minutes. And there's only one unknown in this ratio, which is W. So what we're going to do is find W. So we've got 360 on 83.74 degrees and 30 on W. So you can find W by using solve on your CAS calculator, no problems, or do what I did, upside down both sides, get W, and you end up with W being 6.98 minutes. That is, to nearest minute, 7 minutes. So he will be able to see the bait for 7 minutes. So they're the worked out solutions to question 2. Okay, bye.